As you know, Lambda World is a functional programming conference for the software industry, for the software practitioner, okay? And we know that there is a huge need of training and teaching in the software industry for functional programming. At the same time, functional programming is in the university, in the academy for decades, and we thought that while the strategies and approach to teach functional programming is very different in the software industry and in the world of academia, we thought that it could be a very good idea to come and gather together people that is heavily involved in training programs for the academy in the ivory tower, and people that is heavily involved in teaching functional programming in the software industry, in the kitchen of the software industry. So I hope that we can have a fruitful conversation. And now Pablo will tell you how are we going to organize all of this. Thank you.
Thank you very much. Well, first of all, welcome to Cádiz. This is my hometown, and I think this is the first time I give a speech here, but it will take only 2 minutes. So. Well, the main reason of this event is collecting opinions and experiences and maybe future plans. Okay, so this event is open and is not only closed to this list of speakers, which are people that has already shown their interest in presenting their viewpoints. And, well, we are going to give different opportunities. Each of you, the speakers, if you find your names here, you have 5 minutes at most to present anything. You all that are here can also make any question after the presentation. I mean, 5 minutes to present anything for the speakers and 5 minutes of debate. Okay? And we will try to keep that rhythm so everybody can talk, and in 2 hours you can enjoy the city. Okay? So, well, I want just to add an ingredient. I will talk afterwards. But I think that there are 2 different ways to approach teaching, depending on the previous experience of the students. Do you have any programming experience or not? This is one thing I will want you to, all the speakers, to explain how you approach people that have no experience and people that have already some experience in programming. So, first of all, Eugenia Cheng, are you here? So,
hello. Hi, everybody. Thank you very much for the invitation to be here. It's wonderful to be in this beautiful town. I am Eugenia Cheng, and I am not a functional programmer. I am a category theorist, but I've been doing something analogous to what we just heard about, because I started by teaching category theory in the ivory tower, as it were, and I've been moving more and more towards teaching it in the kitchen, literally, by talking about food in order to explain what category theory is. But before that, I was teaching it in the more abstract kitchen, that is, to mathematicians. And I've gradually been wanting to bring the message of category theory to a wider and wider audience. So I have had quite an unusual career, as some of you may know. I used to be a kind of standard maths professor in a standard research university. And I've now moved so that I am teaching in art school to art students in Chicago at the School of the Art Institute. So they are all undergraduate fine artists, and they have no need for mathematics. They think they don't need mathematics, and they're definitely never going to go into mathematical careers. But I have successfully persuaded them that category theory is wonderful, relevant to their lives, and something that helps them in their art practice. So I have taught every level from graduate students to kindergarten, because I also help with schools. I've also taught middle schools and high schools. I've done a lot of outreach work for schools to show students that there's something much more interesting interesting in mathematics than the boring stuff that they learn in school. And the thing I love showing them most is category theory, because I think the great thing about category theory is it has no barrier to entry. You don't actually need any prerequisite knowledge to do it, because it's very, very basic to start with. The only thing you need is curiosity and a desire to look at things from different points of view, and an open-mindedness to believe, and I have to persuade people of this, but I can persuade people that thinking more abstractly, although it feels like it takes you away from a situation, it actually takes you closer to more situations, because you can make lots of connections between things, and that enables you to understand more things, and therefore it's really helpful. So the image I like to use for people is that we're trying to illuminate things. We're not necessarily trying to solve particular problems, and that's the first mindset that I have to overcome when I'm teaching people, that it's not all about solving problems, because if it is all about solving problems, then if you don't care about that problem, then you won't care about category theory. But it's about trying to understand things better. And I start by saying to people, wouldn't it help if everybody in the world understood things better, especially at the moment? And so what we're trying to do is shine light on situations so that we can understand it better. And if you shine a light very close up, then you get a very bright light on a very small area. And if you bring the light further back, then you get a slightly dimmer light, but you illuminate a broader area, so you get more context into what you're doing. And so the aim is to find the right level for what you want to do at the moment, which is not always very far back. If you want to do something very, very detailed, then you'll need the light to be close up. But if you're trying to understand systems and structures and how they work, that's where a more abstract approach can really help you get an overview and understand how things are connected to each other. And I think for me, what category theory does is it emphasizes connections between things rather than individual things. It draws analogies between different situations so that we can draw on what we've learnt over here in order to do something over here, and more to the point, so that we can draw on the expertise of other people so that we don't have to do it ourselves. So it's all about being lazy and trying to avoid doing more work. The trouble is that category theory in the ivory tower is written for people in the ivory tower, and there aren't so many people who are making the effort to show how that can be learnt by people outside it. And that's why I started doing more and more work to show what it is to people outside it. There have in the past been a lot of very technical textbooks that just show you all the technicality and all the details and all the theorems without saying why we're doing it, what the point is, and what the aim is. And if you start by motivating people to want to do it, then there's more chance that they'll feel motivated to get through those details. Whereas if you just start with the details and no motivation, then there's no chance at all. So I have been doing category theory with art students, most of whom failed math in high school. And even if they didn't fail it, they've forgotten all of it. Most of them can just about add numbers together. But if they have to multiply, then they'll need to use their calculators. So this is the level of prerequisite that you actually don't need to get into category theory. But you do need just to be interested in things and interested in thinking. So my message, although it's not very specific to functional programming, my message is one of optimism, that we can, yes, we can bring this message to many, many people, regardless of their backgrounds, and including, I hope, in the future, high school and even middle school. So I've been teaching category theory to middle school teachers who are convinced by my methods and my examples that this is things that we could do with younger and younger people, so that everyone becomes more comfortable with abstract concepts as they go into life and work and whatever else. Is that about 5 minutes? Okay, wonderful. If anyone has any questions, I'm very delighted to discuss my experiences.
Thanks for the presentation. I'd like to ask which has been the most difficult or weird case you've had to deal with, person that really had a tough time understanding the concepts, maybe because of their way of thinking or because they actually...
The people I find who have the toughest time understanding concepts are the ones who are completely convinced that maths is just about numbers and that it's just about solving equations to find out what x is. And they're so fixated on finding out what x is that they can't believe they're actually doing maths unless there's an x and they've found out what it is. And so that's the main thing, and I blame that on everything that's happened before. But as an extension of that, the people who I found hardest to convince that category theory could be relevant is engineers, who really often think of maths as a tool that helps them solve their problems. And if I can't pinpoint an actual engineering problem that category theory will solve, then they don't think it has any value. And I can't. I do not know an engineering problem that specifically category theory will help them solve. So the other group of people I found particularly difficult are pure mathematicians who are very close to category theory but don't do it themselves. So algebraists. In fact, the hardest audience I've ever had is non-commutative algebraists who are very resistant to the idea that category theory can do anything for them. But art students, children, very excited about it. And tomorrow in my talk, I will show you some of the real-life situations that I use to show how category theory can help with everything. And if it can help with everything, then that logically implies it can help with functional programming, I think.
I think you made the point that category theory can be an easy way in for people who don't know much maths. And perhaps it's more accessible to those who don't know any maths than to those who know a bit or quite a lot, like your engineers. And I wonder if that's another analogy with functional programming. In my university, we teach functional programming to first-year undergraduates as their first programming language. And we find that very helpful because it's a leveler playing field than if we were to teach something that some of the class will be more familiar with.
I think that if people do know a lot of maths already, it's only a hindrance if they have a very fixed mindset about what maths is. And so it can help. If someone has seen a lot of maths that includes category theory examples, but where they themselves have already noticed connections, then if you then show them that all those connections were category theory, then they suddenly go, oh, wow, of course, that makes total sense. Whereas if they are completely convinced that maths is a very, very static thing, it's really about open-mindedness. And that's why at the beginning of my book and the beginning of my class for art students, I spend quite a long time trying to just get rid of the previous notions of what maths is. And some people refuse to take it. I mean, I get people sending me emails saying, you're mistaken, what you're doing is not maths. And they're not a mathematician, and I think, who do you think knows better if they're doing maths or not? Do you even have a definition of maths? I've stuck my neck out, and I have said what I believe maths is. I'll tell you that tomorrow, cliffhanger. But the people who say this isn't maths, I don't think they have a definition of what maths is, except that it's about numbers, and that's simply not true.
Okay, so thank you very much. We will continue.
Thank you very much for having me here. And I'm going to take shorter time because Eugenia already said everything that is important about category theory. So I have very little to add. Maybe I'll just say how I got into category theory. So originally I was a physicist, but then I switched to programming. And I was just doing programming, the low-level programming, then a little bit higher-level programming. Then I went into, C++ and started doing these hard things like template metaprogramming. And then finally, I realized after going through these very hard books about template metaprogramming that these people who write these books, they actually know something that I don't know, and they know functional programming. Because template metaprogramming is totally functional. It's pure functional programming. So I started reading Haskell, and then I realized, okay, everything that they are doing in this horrible C++ syntax, okay? I mean, Scala, there are many Scala programs here, right? Has a much better syntax. Haskell has beautiful syntax compared to C++, right? So I started learning functional programming, and through functional programming, well, I sort of saw that, there are these concepts like monads, functors and so on. What are they? So I went back to math, and I must say thank you, Eugenia. I started watching the Catsters videos, and they got me into category theory. And the other person who got me into category theory was Edward Kmet. I started reading his Haskell libraries, and he just translated category theory into Haskell. So unfortunately, Edward is not very good at explaining things. He thinks it's at such high level that he's not really good at explaining. So I took it upon myself to go through this category theory, read these really, really heavy mathematical books, and then translate them for programmers. Because mathematicians use examples. I mean, if you want to explain what category is, you have to give examples, right? And they use examples from topology, algebra, things that we tend to forget. So I just picked examples from programming, and turned out that category theory is not that hard. It's really simple. At least in the beginning, okay? Things get a little hairy later, right? But explaining what a category is, you can go to kindergarten, and you can explain what a category is, right? Yes, there's really simple, very simple ideas. And then I realized that category theory is all about composition. This is like the science of composing things. And of course, programming is also a science of composing things, right? I mean, you often hear, oh, this is a good library because it's composable, right? I can compose it, the API with itself, and I can compose this library with other libraries, and they work together wonderfully, and so on. So it's like people use this argument, something is composable, right? And then I realized, but after studying the category theory a little bit more, that actually everything, not only programming, everything is about composition. Like everything that we understand as humans, we have to be able to decompose and then recompose. So that was like my moment of truth. This is all about how we perceive and understand this world. That's what category theory is. And now people often ask me, and Eugenia has the same problem, but how can I use it in my everyday? So I'll say something controversial. It doesn't really matter. I mean, is everything that you do has to be related to some practical application? Don't you do some other things also for fun, like, I don't know, watching movies, listening to music, playing instruments, meditating, all these things? Do they help you in your programming? And I think they do. Right? I mean, all this stuff makes you a more rounder human being. So in some way, it helps you in programming because it gives you a little distance to what you're doing every day, right? You're not sitting there just like twiddling bits, right? But you have a better perspective. And you never know when these things become practical. Maybe they will, maybe they won't. And maybe in future we'll all be programming in category theory. Maybe we won't be using these low-level languages, and we'll just use math. And I think that would be a wonderful future. But even if you don't find immediately an application for the things that you learn in category theory, just think of this as, fun, as listening to music, as meditating over mathematics. Thank you.
Any questions?
Well, just going on this thing, the controversy. So I agree with you that it's wonderful to learn this, but I always fear there is a lot of people who approach functional programming and somehow the community gives them the feeling that they need to understand all of this just to become programmers. And this is people get very afraid, and even people who really are understanding think they don't, because maybe they haven't found. So I think that actually, even though I agree that it's fun to learn this, there is many people who don't approach it as a fun thing. They approach it, I need this, otherwise I will never be able to understand all of these people. And this is not very nice.
I think this is the wrong approach, you know, because you feel this tension and you get frustrated if you don't understand something. And it's like, I need it for yesterday and I haven't. This is not a good mindset to learn category theory. You have to sit down, relax, draw a few diagrams, chase a few diagrams. It's fun, you know. And I can, you know, I can give you absolution. You don't have to learn category theory to be a good programmer.
Can I add something to that? I think it's a great point, and I think it's a problem with mathematicians as well, that they've been given the impression from someone that category theory is so important that they have to do it. So there's a backlash where they feel like they have to prove that they don't have to do it. The thing that I like to point out is that they're doing it anyway. Whether they resist it or not, pure mathematicians just are doing category theory. A lot of the things that they do without them realizing it. Just like normal people are doing maths every day, even when they don't realize it, and not just when they're calculating a tip or adding things up in the grocery store. They're doing maths every time they make a connection between something and something else. And so finding some places where you can just point out, well, you can think of that as being functional programming if you're comfortable with it. But by the way, actually it's a piece of category theory already. You already know it. And just showing that people already know it, I find can be helpful to say it's not this extra thing you have to do on top of what you're doing. You're already doing it. Hooray!
It's like one of these plays by Molière where this guy is learning what's the difference between poetry and prose. And the guy explains what poetry is and then says, what's prose? Well, that's what you normally do, you know, when you talk. That's prose. And he said, wow, I've been talking prose all this time. I didn't know.
Bartosz, I enjoyed that, thanks. You said something about maybe in the future we'll all be programming in maths. I'd like to take issue with that. One of the things that computer science, programming language design has over maths, and this is an argument that Dijkstra made many years ago, is that computer programs are very big bits of maths, and programmers, computer scientists, need much better tools for organizing their thoughts than mathematicians do, because they deal with much bigger expressions and much bigger statements of theorems, which is what programs and the types of programs are. So it would be a backward step for us to go back to programming in maths. We'd lose all the abstraction tools and ways of coping with large systems that we've built up over time.
Maybe I should have said that there is a convergence, right? There's a convergence, because there is a convergence also coming from the direction of math. You know, like homotopy type theory that was kind of based initially on Wojewódzki trying to find how to prove theorems using computers, and he found out that, well, math does not have very strong foundations that would be translatable to computer languages, so he started building new foundations for math. So there is a convergence. There is a convergence coming from all directions.
Okay, thank you very much.
Okay, yeah, I'm Rúnar. Yeah, so I'm not a category theorist. I'm not even a computer scientist. I taught myself to program an 8-bit computer at a very young age, and then somehow graduated to like enterprise Java beans and stuff. You know, it was great, but I wasn't really satisfied with like the kind of reuse and assurances and things I could get out of that kind of programming. And so I had a lot of bugs, you know, I had a lot of untested software and unhappy customers and things like that. So I started looking at what can I do how can I get better guarantees? How can I make my software more reusable, more composable, things like that. And so I came across Haskell and functional programming, found this great community that I could study functional programming with, and it was awesome. At some point, I was just sort of doing this as a hobby, like figuring out functional programming and like applying it on the job, sort of like under the radar, like trying to smuggle in some Scala into my Java projects, like hoping nobody notices that I've like, somebody will come to work tomorrow. It's like, man, there used to be like 1,000 lines of Java here, and it's like, oh, what's a catamorphism, So, I found a community of like-minded functional programmers and actually got my first job doing purely functional Scala with my friend Paul Giussano, whom I ended up writing a book with later called Functional Programming in Scala. And we wrote that book because where we were working, a lot of people who were coming from Java or C# or something like that, and they didn't really know like how to approach this, like how to come to functional programming and learn it, and so we started a study group where we all sat down together and we sort of like did functional programming as part of our work. And the book that we wrote, Functional Programming in Scala, is really sort of follows that mantra. Like the very first sentence in that book is, "This is not a book about Scala." Like it's a book about functional programming and about like how to teach yourself functional programming. And I think the most important thing that we did there was to make the book not just like present it, like all of it. Like here's all the stuff, and you need to learn all of this, and then you're a functional programmer, right? Like to your point. It's more like, here are some interesting things. Now go and apply this to your work. Do lots of exercises. Think about this, like chase lots of diagrams, and like take this abstract thing and make it part of your work, and then do that gradually. And so the first part of the book is just about sort of like how functional programming sort of works, like in the very simple, like composition of functions and things like that. And then it's an extended tutorial of like writing several libraries using functional programming. Doing things like parsing and like testing and things like that, like actual work. And then we get to the abstract stuff, like, oh, all of the stuff you've been doing is actually, category theory. So, yeah, and I think that's really I guess what I'm trying to say is that the best way, I think, in order to learn anything, and functional programming in particular, is to sort of chew on it. Right? You take this abstract thing and you think about it and you make it part of your own work. You chase your own problems using it and see how you can, like what you can do with it, and have fun with it. I think a big thing is also making the stakes low, right? Allowing yourself to, like this is just for fun, and if I don't figure it out, it's not such a big deal, right? Yeah, I think that's all I have to say about that. Any questions at all?
Very much.
Well, so I'm coming from the other side. I'm coming from the ivory tower. I work in Utrecht, in the Netherlands. Yeah, all Spaniards will know that's when we lost Gibraltar. So I have to go there every day. And there we try to actually teach functional programming to people who are doing second year course, second year in their degrees, which is kind of nice. It's kind of a blessing. So you get all these 200 students, which have to come to their course because it's mandatory. So that's also a course. They have to come to their course. So they are not as motivated and this is one of the things I found quite differently when I first had to give this course is that most of us, when we talk here, we find people who want to listen to us. And they might not want to listen to us all the time. They are really the people asking the question, why? Why I have to listen to you, and why do you have this? So in order to do this, we've been trying, and I would like to take any idea that you may have about how we can do this. We try to teach them things which are reusable. So years ago, we talked a lot about partial combinators and place evaluation and things like that. But nowadays, we are trying more and more to speak of what's the core of functional programming. So more higher order functions, algebraic data types, and then show by the end of the day, they can learn Scala, or they can learn Swift, or they can learn OCaml, because they know the basics. And then there is this other part about how we make this attractive to them. And we just follow the typical thing. We ask them to make a game, because if you make a game in your course, then it's more attractive than if you make a console application. Although I don't know if the person who gave the Don't Fear the Optic workshop made this. Yeah, that's incredible console game. That was awesome. So that's kind of nice. It's been working nice. They write some kind of asteroids game. But that's also a problem I find, and I also would like to listen to your ideas. So we are able to tell them how to write Haskell, but we have been failing a bit on how to write good functional programs. So you see programs which are functional in the sense they are written in a functional language, but that don't follow any of the things we like to do. They have to separate pure and impure parts just because Haskell does it, but it's not something that goes with them. They define hierarchies of classes like they were doing Java instead of doing Haskell. So that's something that it's been hard to do. So yeah, that's more or less what I wanted to do. So yeah, we try to do this, but it's been quite a challenge to try to sneak these ideas on minds who might not be as receptive as they might be, and where you have to really tell them, oh yeah, this thing is gonna pay off in a few moments. Wait. So that's it. Thanks.
Hi, so let me see if I understood correctly. You're looking for some ideas to motivate your students.
Yes, everything. Well, yeah.
I got one that worked, or it's working, and it's based on pressure. So we have the software engineering students, and we force them to work with the electrical engineering students and the mechanical engineering students. And we basically give them like this kind of problem, like how do you represent a turbine in software? You can express this with FRP, for example, functional reactive programming. And they need to deliver that. If they don't, the person that is doing like the mechanical engineer course, they don't get their grade because they don't have the software. So it's like they are their bosses, and they need something that works and doesn't fail. So this kind of
that's like awesome and evil at the same time.
Yeah, it's really evil, but it works. And both of them, they deliver what they need. So the mechanical engineer needs to explain to the software engineer how a turbine works in order to have a software that actually works. The same for electrical engineer. Like we needed to represent a digital signal processor, and again, we used the same strategy. We put the software engineer to work with the electrical engineer students, and they needed to deliver their software working.
Thank you.
No, I know, but it's every domino effect. It's always like, you can blame the other person from failing. You don't want to.
Okay, I want to know if you said that for your students, what you do is a video game. But I'm having some troubles now because I come from the C++ community and I wanted to learn Go, for example. So what I did was, okay, I'm going to take some problems that I already know how to solve in C++ and I'm going to solve them in Go in the right way that Go would do it.
Yeah.
So I'm going to implement, for example, let's go to say some command line tools that the Unix have, the grep, word count, and those kind of things. Because the language really is, it shapes those kind of problems. With C, with functional programs like languages like Haskell, I don't know which programs should I program. You know, I don't know what to code when I want to learn. Like, I'm not sure if I am explaining well.
Yes.
Are you following me?
Yeah.
Okay. So which kind of, let's go to say that you have programmers and you want to tell them, okay, solve those problems in Haskell. And I don't want a boss of the mechanical engineer who tells me what to do. How would you do it?
Yeah, when people ask me, I would like to tell them, write a web server. That's awesome. So the tools we have in Haskell are completely different, but it still use a lot of functional things. So you can take, the servant or ASIN, and everybody and every software engineer wants to know what JSON is and wants to do this. So that's the thing I like to tell people who are already programmers. Of course, you cannot tell this to students because they have never written a web server, and you don't want to take yet another month for them to be able to make the practical assignments. But yeah, I think that's at least that's what I use to learn when I was learning all these things: web servers, client server applications. Yes, these kind of things are nice, are as big as you want them to do. You can write a small web server which just says hello and your name, or you can write a web server for a bank.
Hi, Alejandro. Like you, I struggled with what to teach in a functional programming course for students who demand it be useful rather than just an end in itself. And the solution I came up to is perhaps what's been suggested by other questioners. I think the killer application is domain-specific languages. So if you're looking for what to program, or if you're looking for what to put in a course that is compelling to people who are going to build on that and do other things, show them a whole bunch of domain-specific languages for digital signal processing, for robotics, for music. You can even get your parser combinators back in that way, and say, look, you can do these things, and implicitly challenge them to think about how to do them better in another language, and hopefully, if functional programming is what we say it is, then it's the tool for that job.
Okay, I'll think about it. That sounds like an interesting idea.
Hi, thanks for that. I think that teaching people who don't want to be there and who are forced to be there is a really interesting discipline for the teacher. And there are two things you can do. You can be a bad teacher and you can exploit the fact that they have to be there. Or you can be a good teacher and dig really deep in your own motivation and understand why you believe that this course should be compulsory. And if you truly believe that there is a reason it should be compulsory, then you can transmit that to the students. And then if you believe it well enough, you have to convince them that they can believe in it too. And one of the reasons I quit my maths job, the University of Sheffield, was because I didn't believe in the stuff they made me teach. And I couldn't, with a clean conscience, continue to teach it. And I was the kind of teacher, when I then taught calculus, I was the kind of teacher who just skipped pages of the book because I thought they were pointless. And I said, I don't even know why we're doing this. And if I don't know why we're doing it, I can't teach it. But if I believe in it, then I will transmit that. And if the students want it to be useful in a very specific way, then it's even more of a challenge to convince them that there are different meanings of the word useful. And it doesn't have to mean this solves your problem immediately, but that can involve, especially with young people these days, as it were, the getting over the short-term benefits and getting rid of instant gratification, and saying sometimes you front-load some work, which means that you never have to do that work ever again. And isn't that great? That's what I see.
The problem with this also, that's nice, but at the end you have to grade them, and that's I guess where they have really a short-term objective, which is passing the exam. Even though you tell them that's going to be for life, they have to do both things. They have to get this thing for life, and at the same time they have to pass the exam, which is going to be in 3 months' time. So
I have to admit that's another reason I quit my job. And I now teach at a university that has no grades.
Just a very short, I think the killer app for functional programming should be definitely parallel and concurrent programming. Anybody who's struggled with mutable data and got into deadlocks and so on will understand.
I wanted to suggest something similar to what Bartosz said, is actually getting the best things that functional programs do, composability, parallelism, etc. Those things that you actually tell your students that those are the benefits of what they're learning, and transmitting through developing applications that exploit those characteristics, like parallelization and etc. That's exactly what he said. So yeah, that might be somewhere to find a motivation, so to say.
Yeah, thanks for the feedback.
So hello, we are Javier and Rafa. We are from Spain, from Barcelona, and okay, and we have a kind of different background from you all, I think. So we are more like engineers, classic engineers. We are like in the enterprise world, like a startup world, and now we like to do things simpler, good done, we think. So we one day, well, Javi created a YouTube channel called CodeLHEV, and we started talking about solid, clean code, and this kind of stuff. So that's great for us, and I think it's great for people because people keep learning, and then they asked us something that, can you do this, please? And we try to do this kind of videos, and we get some popularity in the group, so we gain our responsibility in this group. So we started to take this more serious. So like a month ago, we created a course platform, a cheap course platform to create some videos and a course that you can learn, and more or less is that we are doing now. So,
yep. Some things that has to be said, or more than that, that we can bring to you in order to put some value here. Juan asked us to share some tips or what worked for us and what didn't work for us. And what we did was just share videos on YouTube, creating a new project in Scala using the SVT new command, sharing a GitHub repository with a template in order to break that blank page syndrome of how do I start writing Scala. And that was quite useful for us because we could use it on the Scala Barcelona meetups. So more people come to the coding dojos and they bring their laptops already configured and ready to jump on the sessions. And we also did some screencasts about refactoring.
So screencasts also, we did some interviews to people in the functional world to show people what is functional programming, how can you resolve this. Because we're saying that, so we like our code simpler, we like to have our domain, only our domain, we don't have to have infrastructure, but you have a future. A future is not in your domain. How can you access from the future? You have type classes, you have this, so we did some interviews with, for example, with Juan from our labs, with Maximum, yesterday with the Raul Raja, and this, and also with the course we have a kind of evil plan, so we have a SQRS course, and we love that people in Radium in Barcelona that it's we are most popular, but also in Spain, we love that these people could start coding in Scala, do functional programming in Scala, because if someday we want to change the job, we want to go to a company that does this. Because in Spain, there are some companies doing functional programming, but it's not the normal. The normal is the PHP world, like spaghetti code. You don't like this. So we are doing some crossings. For example, teaching CQRS, in some point this is an abstract language course, but we are showing examples like the command bus. We are doing the command bus in Scala. So, because we don't want to return a future, we want to test in synchronously with identity and use futures only in production. So we are doing the examples in the Scala using type classes and telling the user, hey, this is in Scala and this is the class. This is the way that you can abstract from this. And if you want to know more, there's another course that if you're paying this, you can see this other and you can learn from this.
All that ends up at the end on having a practical approach. Like, I'm a programmer and what I'm interested in is just solving problems in order to put in production code which bring value to a supposed user, and that's it. And if I can do that with less work, because Scala supports future asynchronicity and actor models to do a chat server or whatever, I'm interested into that kind of stuff, but as a side effect, we could say. So that more or less could be our experience, if you have any doubt.
One question here. So you might characterize your approach as kind of bootstrapping. I mean, the idea is to get all these programmers who face problems, okay, and to let them start solving those problems in a more effective way using new techniques from Scala and so forth. And what about the motivation? I mean, do you have these problems of motivation that Alejandro told us about their students, or the people that you get is hugely motivated?
I think we're lucky because people is usually motivated because they are paying for learning. So if you are paying because you want, not because your parents told you that you must go to the university, because if you don't go to the university, you are nothing in the world. So people is motivated, more or less. So if you can turn on the switch and tell, hey, this exists and you can do this in this way, I think it's a good way to do this.
We can talk about the experiences on the previous company, on Lego, where there were 40 developers, and we started developing Scala for a specific need, but then we started to spread the interest on Scala, and there were developers who were more interested in these kind of things, and there were developers who doesn't. And we started by the need of a specific team, and then we moved on to another team, sharing a member of the previous team, and so on, and then doing workshop on a weekly basis. But that was a problem because the developers coming to the workshops, then they don't face problems on their daily basis jobs. So they felt at the end not so motivated. So the best approach in this kind of scenarios that we have faced is just to bring people from teams who are actually already writing Scala to other teams who want to start because of a need.
Okay, thank you. More questions? Okay, thank you very much.
So hi, I'm Jeremy Gibbons. I'm from the University of Oxford. I'm going to tell you a little bit about how we teach functional programming in Oxford. I already made my main point in an answer to Alejandro, so I hope you'll forgive me if this comes out as a bit of a plug for Oxford, but I'll be telling you something of the context. So we have a part-time professional master's program in Oxford. It's something that's been running for over 20 years now. We have 2 master's degrees, one in software engineering and one in software and systems security, and plans for more stuff. And it's designed for people mostly like yourselves. It's designed for professional developers and people working in the software industry. They don't have to be programmers per se, all sorts of different roles. But the teaching we do is in 1 week intensive modules. So I teach a course on functional programming, and it's Monday to Friday, 9 to 5 for a week. You come to Oxford, you get hit over the head for a week with functional programming, you go home with the take-home assignment, and that will give you some introduction to functional programming. And we have many modules. You do 10 of those, and a small dissertation, and you get a master's degree. And like Rafael and Javier were saying, our students choose to come and do this. They pay to come and do this. We charge fees, and we charge quite significant fees. So nobody comes to do it with us who doesn't want to do it. It's a great privilege to be teaching interesting, grown-up, motivated students rather than sulky teenagers. It's great fun teaching on this program. It's exhilarating. One of the main points that helps us structure the program is we're teaching a software engineering degree, not a computer science degree, and we're teaching it to professionals, not to undergraduates. So we make the point. It's all about software development in context. It's not writing programs as an end in itself, much as I enjoy doing that for myself and my research career. That's not what I do for my teaching career, and that's not what most software developers do. They have jobs and they have problems to solve, and the software is part of a larger ecosystem. And so we built a whole program around that. So I think it's rather like other professional subjects like law and medicine. You can go to university as an undergraduate and you can study the principles of law or the principles of medicine, but that doesn't make you a qualified and safe lawyer or doctor. That makes you it gives you the foundations for it, but you then need to go and do professional study. And I think it's the same for software engineering, and in particular for my functional programming course. You might have done an undergraduate degree in computer science, and that tells you stuff about automata and operating systems and databases and things, but doesn't tell you anything about the professional context, the larger context of software development. And we're very poorly equipped in a university to present that stuff. We can't provide that large-scale context. We can't sort of faithfully replicate it in a university. So instead, we expect the students to bring it to us. So the students have a whole bunch of experience that's complementary to ours, and we gain a great deal from that complementary experience coming our way. So we expect the students to bring the knowledge of how software development fits into this larger context, and what the issues are in doing that, and then we try and have a dialogue about how to address these problems. In academia, we can provide part of the solution, and then from the professional world, you can bring the other part of the solution. And so the classes are a great discussion and dialogue, and very exciting to take part in. So the students, as I say, all people like you. I don't want to use up too much time, so if I'm here tomorrow as well, if you want to chat to me about this, do come and grab me. We have a full syllabus of currently 42 subjects, of which you choose 10. So there are many different ways of doing a degree on this program in Oxford. I did the combinatorics once. There's about 800 million different master's degrees you can do by picking 10 of these modules. But there's one in functional programming, which I teach, hence the reason for this, this spiel. And how do I teach it? I don't try and deliver the undergraduate computer science degrees functional programming course to professional software developers. It's a different audience and you need a different course. So whereas for an undergraduate course where I'm teaching people the fundamentals and the principles of things, I might major on the theory, on proofs, on monads, on laziness, on language implementation techniques. There's a whole bunch of stuff that's very interesting about functional programming, but it's divorced somewhat from the context, from the application. So instead I teach functional programming as a means to an end rather than the end in itself. And so, as I said to Alejandro, I've tried to structure the course around tools for modularity. I don't expect students to come in, do a course, 1 week course in functional programming, and then go home again and be functional programmers and immediately be able to sort of turn their whole company around from a Java shop into a Haskell shop. But I expect them to go out to be better Java programmers or Scala programmers or C++ programmers or whatever it is. So I've thought about this. I'm still not entirely happy with where the course is, but my feeling is that structuring it around domain-specific languages is a way of making a course that presents functional programming strengths and explains why you might be interested in this, but also gives you a whole bunch of techniques that you can then take into many other languages with more or less pain, but it shows you a new way of thinking about programming. So my message is about how to teach functional programming to diverse audiences, how to teach functional programming to professional software developers. You have to find the way to speak to your audience, how to find the compelling sell to them, and I think domain-specific languages is it. So that's the point I wanted to make. Are there any questions? I have familiar ones to you. I do have parser combinators in the course, and I describe it as a domain-specific language for writing parsers. Use some of Paul Hudak's examples, so music and robotics and so on. There's a take-home mini project every iteration of the course, and I still haven't figured out how to get out of the assessment bit. I have to write a different one every time, and usually it's a domain-specific language for a new problem. That I have to keep thinking of new problems. I've been teaching this course for 20 years, and it's a lot of new problems. But, lots of games, puzzles out of the newspapers. I thought your web server was a good example. So there's lots of stuff in describing what goes on inside a web server. So I might nick that one. Thank you.
Thank you. I think all this sounds great in many ways. I'm just wondering if there are, if all the academics teach courses on it, or are there some who are skeptical of the professional aspect of it and the usefulness of it?
So that's a very good point. We did for many years feel like second-class citizens in the department. There were those who taught the undergraduates in the Oxford traditional tutorial system, looked down on this education external stuff. It's two different classes of people. Because of these 1 week courses, our timetables just clash with everybody else's timetables. Everyone has a lecture every Tuesday afternoon across the whole term. Clashes with one of these courses. So it's one group of people who teaches to professional software engineers and a completely disjoint group of people who teaches the full-time students.
And do they still look down on it?
Not anymore, because we're the most successful bit of the department now.
Excellent.
Teaching-wise, at least.
Yeah, thank you. I was just wondering if you run into trouble with attrition. So in training professional programmers, I often run into, if it's a multi-week course, by the end of week 10, there's maybe 2 people who are still sort of with you, right?
So we don't. It helps that we have very small classes and quite a lot of personal attention. We're well staffed, and of course the salaries are paid for by the student, the fees for the students. So we charge enough to make that happen. There are people who come and do 1 or 2 modules. They sign up for 10. They pay each module fee as they go, and then they discover that this is not right for them and leave. That's fine. Don't force them. And because it's part-time over 4 years, and these are grown-ups with families and mortgages, and they emigrate and they collect new babies and things. Sometimes life gets in the way, and they can't do it anymore. But we don't suffer attrition. People have chosen to come. We demand that they do their internal financial analysis and be persuaded that they can pay for it. So unless something's gone wrong, the finances aren't a problem. Maybe the situation's changed, and that changes their mind. But no, we have I don't know, 90% completion rate.
Wow, thank you.
The secret is to charge money for it. Once you've paid, you're invested in it.
Well, it's my turn. Well, I'm not very experienced in functional programming, But 2 years ago, when Jorge Galindo told me about Scala and all the wonderful things that were happening around functional programming, I thought I had to change some things in the university in Seville. When I was a student, like 20 years ago, I was taught Prolog, Lisp, and at that time I was a video game programmer, and I thought that I couldn't use that kind of knowledge because it didn't perform at all. But things have changed suddenly, and everybody's building things using this new kind of paradigm. But our way of teaching hasn't changed because bureaucracy is everywhere in the university, and I thought, how could I change a little bit my environment? So I decided to build some kind of experiments with students that wanted to develop their grade project. And my first intention was to tell them to build anything with Scala, Haskell, or whatever functional language. But most of them didn't find a way to start from scratch to build those kind of stuff. They had always thought in an imperative way. Even some of them even knew what an object was, or in classes. But the imperative world is all around in our studies. So I decided to change my mind, and I started with the way student thinks. You're shown a lot of information, you're given many data, and there are dots, small dots in your mind, and as time goes by, I think that you start to connect those dots. You draw lines, and things start to make sense. And when you're in the industry, you're still connecting those dots, and when you look those dots in the distance, you may see the big picture. But I think that all the information we're given in the university needs some time to make sense. So I decided to apply another different focus and start with technology that demanded the students to learn some ingredients in functional programming, pure functions, for example, immutable data, and those kind of things that make the students discover that there's another world around that's not only imperative programming. So I decided to let the students learn React and Redux to build from just the front end of a web page. And they didn't understand what they were building. They were able to follow some tutorials, but when they wanted to make some changes, errors appear everywhere, just because they didn't understand the paradigms behind. So they always came back to me to let them know how things work. And it's a completely different way to teach, because you're not giving information to the students that they don't know what it is for, but you just solve problems they have, and they feel that they are their problems, not your problem. So it's an inversion on the dependence, on the way you teach, the way the students learn, and it's a way to deliver the responsibility of students to learn new things. And that's a very small experience that has just worked in a small environment that makes me think that I can build bigger things. Maybe next year I can tell you much more information, but I just wanted to share my experiment. And well, if some of you have any other similar experience or whatever, show it. That's all. Thank you very much.
Well, I've been changing a work right now, and I'm one of the things that has been asked for me is bringing functional programming into the workspace. And one of my main issues I had in the last iteration doing something similar was people just don't give it a care about functional programming whatsoever. So what I started thinking was, well, just give most of what I do is in Node.js, and was just giving them some of the main concepts, like, okay, just make it immutable, just try to get pure functions, or just try to make parameterization easier to think. Those kind of concepts you might have in any functional programming language. So what I found, or might find because I still haven't put it into place, is that they end up in something similar as you have described. They start finding those stones in the way, and they start reconsidering how they structure their own programming, because you can no longer do many things if you have immutable states. So yeah, what you're saying makes a lot of sense, and I hope your insight might prove somewhat useful in my upcoming months. So thanks.
Thank you. Well, you said an issue about immutable data. The way we are still teaching data structures and how to deal with them is that you have to clone a whole structure and modify a bit. And that's not the way things work. That's the way that the conceptual way, the implementation is completely different and it performs. But it's like a shock when they see that. It's not the way I've been told how to deal with data structures. And that's another problem I found with immutable data, for example. That makes sense. Okay. But you have to know how a compiler works, and you need a lot of information to connect all those dots and see that you're watching a completely different universe.
I'm an Android developer, and from there you see for a couple of years reactive frameworks have really taken off. And now, as sort of like a logical extension, you get more and more immutable data, and that's exactly seems the moment that people start realizing, including myself. I'm also still learning. That's like, wait a minute, I'm starting to apply functional concepts, and but it's also actually the hardest thing for my colleague developers to just keep axial state immutable. So I wonder, is this something that you have also seen? That actually the immutability of this state, that is the big step for them towards functional programming, and not so much like the terminology or or like the right operators like maps and flat maps and whatever. It's really the moment that they started like to be enforced that an immutable state, that they don't know how to solve the problem anymore.
Mm-hmm. Yeah, well, I haven't heard your question.
Right. So it seems that for most developers now in Android, there more and more these concepts for functional programming coming in. But the problem is they've never done functional programming.
Yeah.
So they're living in a Java 6 world, basically. So the whole thing that's like you have your state that is immutable seems to be the hardest thing for them to learn over the fact that functions can be composed and everything. That actually for them is not just a hard step. It's really the immutability of all these of this data.
That's one of the main points. I mean, I can speak with a huge experience because the experiments with with people with short experience that even most of them don't know the paradigms behind even object-oriented programming, so they are very polluted with a lot of information that is imprecise or even incorrect. So, well, that way of thinking, it's a different way of thinking. I mean, functional programming is like another paradigm, but it's a 30 years old, well, 40, 50 years old paradigm. It's very old. It's like we are rediscovering this kind of paradigm. We have to change our minds, and that's a shock for experienced or newbies, because we are always telling that they have to think in a certain way, and as new ingredients of functional programming are added to programming languages, the way we have we think it's different. So that's one of the points where I see that people blocks.
Hello everyone. My name is Juan Jose Vazquez. I am the CTO and partner of a small company called Texisa. I have a degree in physics, but I've never worked as a physicist. I think that helped me to have a bit of background or large background in mathematics, but not in abstract algebra and category theory or that kind of things that you were talking about before. I've been working in the software industry for 18 years, mainly with object-oriented programming. But since 2014, my company and I, we decided to shift to a new set of technologies, starting with a new paradigm as a language. We started with Scala, and another set of tools like Cassandra, Apache Kafka, Apache Spark, etc. Mainly because we were building a new set of products, of applications for the energy sector that needed to live in the cloud. So we found mainly three problems that we need to tackle. First one is concurrency. The second one was distribution, and the third one was eventual consistency. So these three topics were key in order for us to shift our mindset and look for something else in the ecosystems. Some caveats. I'm not a functional programming expert. I have no, as I mentioned before, I have no abstract algebra or category theory background, nor come from academia. I'm trying to catching up quickly, using my weekends, my nights, and stealing time to my family. And the other caveat is FP, functional programming, was not as an end. It wasn't an end of itself. It wasn't the priority. We arrived to functional programming searching for better support for concurrency and distributed system, and so on. So, but to be honest, FP was a happy finding in the end. The other thing is that we had to tackle too many changes at once. Not only to shift the paradigm from imperative programming to functional programming, we needed to change a lot of things more. For example, from a relational database to a NoSQL database, and so that kind of thing. So it's difficult for me to separate the difficulties I found trying to apply functional programming in my company for these other things that also matters. As I mentioned, we chose Scala as the main programming language in this new set of products. In 2014, it was a pre-Kotlin era, so Scala became a reasonable choice for a better support for concurrency and distributed systems. Also, we had a deep knowledge about how the JVM worked, so we wanted to take advantage of this knowledge and the maturity of the JVM. Although Scala, it's true that it's not a pure functional language, in my opinion, offers a good support for designing DSLs and doing statically typed declarative programming, so we are happy about that. But as a downside, we found Scala too large. It's the size of the language is huge. Not in terms of syntax, but in terms of features, in terms of idioms, techniques. So it was very difficult for us sometimes. You know, it demanded a very hard cognitive effort to recognize the idioms that Scala community was using. So that part of the language was very hard for us. The learning curve is also very steep, so what was difficult for us. A question that I have to answer quite commonly is why not Haskell? Okay? I love Haskell, but we didn't choose Haskell basically for two reasons. The first one I've mentioned before, because of the maturity of the JVM. We wanted to take advantage of that. And I'm not sure about this, but the perception of certain immaturity of Haskell in distributed programming. I don't know if that's real today, but my perception in 2014 was that that support wasn't mature enough for us. I'm aware about Cloud Haskell and so on, but I think the maturity wasn't enough for us. The second thing I wanted to share with you is how is our training process in my company, Texisa. Basically, we follow a first step, which is we call onboarding. It's a 2-3 weeks period of guided self-training aimed at learning the Scala basics. The second step is formal training. It's intensive external training on functional programming in Scala. The third stage is learn by doing, basically. Developers learn from each other by imitation, working together in projects. And the last step, when these engineers already have a good grasp of Scala, is defining. They're trying to reach, they start working on defining and implementing libraries and building blocks and best practices. Okay. What worked well for us, three things. We try to stick to the basics for application code. You know, we apply immutability, referential transparency, algebraic data types, structural recursion, and so on. We'll leave more advanced techniques for libraries, for example, generic programming or higher conduct types, that kind of thing. We leave them for more advanced stuff. And something that helped us is trying to forget all the stuff we don't need. For example, in Scala, there's something which is self-types. We don't use self-types at all because it's not useful for us. So we forgot. Some findings that I'd like to share with you: sell the benefits, not the tools and techniques. So, for example, if you want to sell why referential transparency is great, you need to say better that you are going to reduce the number of bugs, especially under refactoring. If you want to sell declarative programming, you need to say that improves readability, makes clearer the intention. For example, about category theory, I think that provides patterns that leads to coherence, reusability, etc. That kind of thing. Sell the benefits and not the tools. Okay. Be practical. I think this is very important, at least in the industry. Try to write the best code possible at any time with the knowledge you have at that time, not with the knowledge you would like to have tomorrow. You need to take advantage of your knowledge now, and don't push too hard to get them, because mastery, I think, will come with practice. Fight against the imposter syndrome. Celebrate your achievements, even if they weren't reached in the most academic way. Believe in yourself. Avoid holy words and radicalism. For example, light band scala versus type level scala, cats versus scala set. That leads you to procrastination directly. So try to avoid them. Don't let anyone tell you how to do it. You know, the cool guys excel at abstract algebra and category theory and so on, and FP in general, but still you are the one who better knows your domain, so you are for sure the best for the job. And the best is the enemy of the good. FP has a lot of techniques that will always allow you to rewrite your code in a better way, but you need to learn when to stop refactoring. I'm finishing. Keep a pace. Sorry, keep a pace that your team can follow. As a technical leader, you be sure that your team is aware of your improvements. Spread the knowledge and share with your team. Encourage to participate in open source software. And the final one, I promise, is careful with the level of abstraction. Leverage your domain knowledge to be concrete. Don't miss the opportunity to be specific in your application code and more abstract maybe in libraries and building blocks. So thank you so much for your attention.
Judith, tell us that you chose Scala.
Sorry.
3 years ago.
Yes,
As of today,
in 2014.
As of today, you would still choose Scala? If you had to make that decision again?
If I have to learn Scala again from scratch?
Yes.
I mean,
as of today,
I will assess Kotlin, for example, but I think I still choose Scala as my first language because I think it has a good balance between practicality and versatility, basically. So yeah, I will choose Scala again. I continue studying other languages, for example, Haskell or Idris even. But in my humble and personal opinion, in some areas, especially Haskell, has to improve a little. For example, for distributed systems.
Thank you.
Thank you so much.
How long did the first batch of the team take to from starting to feel more or less comfortable actually being productive with Scala?
To be productive with the basic knowledge of the language
being settled.
Yeah, the basic techniques as I mentioned before. To be honest, I think it's around between 3 and 6 months of time.
And actually feeling even that they would choose Scala before Java, for example, that I think it would take much longer, right?
Yeah, I think so. At least they tell me that, so I have to believe that.
Okay, thanks.
Thank you.
Could you say some words about your development process in your company?
Yeah, we follow basically Scrum as a methodology. So we build a team that have some backend developers, front-end developers, and the Scrum Master and the product owner and so on. They design the solution. Our architecture is based on basically microservices architecture. So they design the solution. We try to always improve our process, including new techniques, but we need to be practical on a daily basis. So we also reuse a lot of stuff we've made before. So basically, that's the process we follow.
3 years ago, you choose Scala to start the project.
Yeah.
You told him that you take 3 months to 6 to have a product made.
Be productive, yeah.
when you formed the team, it was new programmers or old programmers that have to learn Scala.
They all had to learn Scala. Yeah, they all were Java programmers basically.
All Java.
Yeah, all Java
Okay.
programmers. So we needed to help them to make the change. Before that, I had to learn Scala and the other stuff, and then I helped them to make that big leap, in my opinion. Yes.
Any other question? Okay, thank you very much.
Thank you so much for your attention.
Okay, now it's my turn. What we have been doing for the last 2 years in my company, Tabla Computing, we have invested a lot of effort in training programs. For the last 2 years, we have given around 40 training courses that were on functional programming, on purely functional programming. I mean, the goal was not to teach lambda expressions and higher order functions, but to teach functional, to teach attendees and programmers to implement purely functional architectures based on DSLs, and so forth, monas, applicatives, etc., etc. So it's quite an intensive course because it is given to software engineers. It is not given to undergraduates, okay, and it is given to people that it's highly motivated because they came and they pay for the training, okay. So that part of the problem of motivation, I think that for us was more or less solved, okay. Still, these guys, and there are some of them here in the room, okay. These guys are really good software professionals, and these guys, well, they know their job and they are used to use techniques that, well, they seem to work, okay, for them for most of occasions, okay. And our major problem, the major problem that we have in order to introduce purely functional programming abstractions was to convince them that, well, they actually have problems when they use the techniques that they use, okay? So if they use abstract interfaces, okay, conventional abstract interfaces to implement their APIs, what we found really useful is to show the problems that they actually have when they are trying to program their applications using those techniques. Okay, so this way and this approach of starting from problems that they actually have and starting from the way that they actually program. Okay, we found it the most effective way to introduce the value of the abstractions from purely functional programming. And it is from this process of rediscovering type classes and rediscovering monads that we found that it was the most effective way to understand the value of abstractions. So we agree very much on the value of abstractions, but in the methodology that we found most effective to prove to show the value of abstractions for reusability and for solving more problems in a more effective way and so forth was to rediscover these abstractions, starting from the problems that people have when they do not use them. Okay. Well, this is more or less the first message that I would like to give, or the first lesson that we have from our experience in these 2 years. And the other aspect that I would like to comment on is that when we are in the process of rediscovering these abstractions, in the process of rediscovering monads and type classes and so forth. What we think is also really useful is to show that we are really not doing something really different to the things that we were doing previously. So, for instance, when we are teaching monads, what we emphasize is that what we are doing when we are doing monadic programming is simply imperative programming. And imperative programming, from a conceptual point of view, is programming in such a way that you structure your programs in steps and then do this, and then return this value, okay? And this way of structuring your programs is exactly the same way that you use when you are programming with monads. So it is, I mean, Haskell is well known to be the finest imperative programming in the world. Okay, programming language in the world, and I think that this is important to be emphasized. That okay, you like imperative programming and you need imperative programming for your application domain. Then don't worry. When you are doing monadic programming, you will be doing imperative programming. Only that you will be doing at a higher level of abstraction. Okay, in a way which will allow us to be more effective. Okay, but you are doing imperative programming and you like APIs, no problem. You can still program with APIs using type classes in a much more effective way than using conventional abstract interfaces. Okay, I very much agree that DSLs are the killer application of functional programming. Okay, but in our experience, what we understood is that in order to come to this declarative paradigm, it's very important to show the pitfalls and the defects that you have when you are not being purely declarative, and to start from the problems that you have when using conventional abstractions. Okay, well, that's the two major points that we got. Thank you. Any question? It
was nice to listen to talks from everybody, but sort of my final feeling, it's kind of sad, because you all mentioned that the way in which we can tell people that they should learn functional programming is essentially by teaching them how not to program, then failing miserably, and then come there and say, hey, I'm here to tell you how you should do this. And, you know, for the perspective of somebody who wants to teach undergraduates, this is kind of depressing, because somehow the imperative programmers have the feeling that they are doing is good, but then we know that they are going to fail in 5 years. So it's not a question, but more a reflection. Like, it's really the only way we can teach functional programming is by having other people doing wrong and then saying, hey, actually, we should have been doing this all this time. Why can't we do this? That's kind of...
No, I don't have experience teaching undergraduate functional programming. Okay, but from my experience, what I know is that the most effective way to teach functional programming to software professionals, okay, is, I mean, it's more or less the way that I mentioned. I don't think that it is the only way that if you start from scratch with some student, they won't appreciate the value of these abstractions. I'm not sure. Sorry, I cannot. Not fit myself in that problem, in that situation.
That's not a question. It's more like a reflection from listening all of you.
Yeah. But it is because it is a kind of audience that we have. Okay, that's the way. Okay. Thank you very much.